Hello everyone, my name is Simon Pearce. I work for a company called Sys11 in Berlin. We are a managed cloud service provider. We have a booth here, so if you would like to talk to us later on, feel free to come by. I'm going to talk about Gateway API, so the topic is Goodbye Ingress Hello Gateway API. Okay, so just give you a quick rundown about myself. So, as I said, my name is Simon Pearce. I've been working for Sys11 since 2013. My hobbies are basically anything Linux-related stuff, tinkering with Raspberry Pis, which I like to do at home, K3s and micro K8s. And if I'm fed up with computers, I like to go out and do a bit of cyclocross or gravel cycling in the forests of Brandenburg. Okay. So let's quickly go through the agenda with you. I would like to talk about application routing, the existing and stable Ingress API, of course, the new Rising Star Gateway API, which this talk evolves about, a bit quick, brief talk about migrating existing Ingress rules, which some of you might need. Cilium CNI, which I basically chose for this talk. As I said, this talk is, of course, biased, so I made certain selective choices. These, of course, can be changed. So there's multiple ways of implementing Gateway API. I will talk about this a bit later on. Then I would also like to talk about some Gateway API Envoy-related issues that I encountered while I was setting up the demo and trying to get everything up and running, just so you're aware of this. And then at the end, I would like to show you a demo, so hope everything works, and show you how Gateway API works. Okay, so first off, application routing. Most of you are probably familiar with application routing. You have some form of HTTP-based application generally, and you would like to route traffic to this. So within a Kubernetes cluster, deploying a pod does not mean that this pod is public, available, or accessible in any way. So you're going to have to find some way of publishing this so the outside world can see your application. So this is the first thing that you typically want to do. You have some form of domain, and you want to point this to an IP address, and this then to some form of Kubernetes service within your cluster. You typically want to support TCP and maybe UDP, depending on the type of application that you're trying to deploy. Typically, most applications would use TCP. You would probably also like something like cross-namespace routing. So the controller that accepts the traffic may be in a different namespace than the application that you're routing the request to. And this is also important, which I'll go into later on a bit more, for separations of concern as well. You typically want TLS, SSL certificate support. So you need some way of being able to, in a Kubernetes world, to dynamically issue a certificate for your applications and for all the subdomains that you may have. You may want to have something like mutual TLS, which you can also directly use in Gateway API, but this could also be used through some form of service mesh or something else. So this would typically mean that you would encrypt traffic within your Kubernetes clusters. There's multiple ways of doing this, and I'll definitely briefly talk about one of them. And hopefully, you may consider using something like network policies. So network policies is also something that can be utilized by Cilium. You can basically create policies to define which traffic is allowed to reach which pod. It can be very complex, it can be very simple. You can definitely shoot yourself in the foot if you make mistakes, like maybe not allowing DNS traffic or something. But it's definitely something which can be a lifesaver if someone actually manages to break into your cluster. It can be like that additional line of defense that you have to stop someone maybe just starting a pod and being able to access the outside world, because he may not be able to do this. So network policies generally do make sense. A lot of people avoid them because they either find them too complex or they're maybe not aware of the way they need to be configured. But if you have the opportunity, definitely give them a try. Okay, so let's talk about the existing Ingress API. As I said earlier, this talk is definitely biased, and the existing Ingress API is still the stable API. It was the first Kubernetes API for application routing. It's been around for a long time, and it still does a good job today. And just because Gateway API exists does not mean that Ingress is going to be deprecated within the next 6 months. This is definitely not going to happen. I'm pretty sure about this. So it's, as I said, it's a stable API. There are multiple adoptions, so you could use Ingress with Cilium as well if you would like to. There's the Nginx Ingress controller, there's traffic, there's various types of Ingress controllers that you can use. One of the big issues with Ingress currently, or which is probably not going to change, is limited protocol support. So Ingress only supports TCP, so nothing else is supported. If you need any form of UDP traffic, anything else, this will not work. And you also have a kind of hacky configuration via annotations, which can allow application developers to override certain configuration within the Ingress controller itself. And if you look at this, this is something that I took off of one of our Keycloak servers. You can already see that this already looks a mess, and I've seen a lot worse than this, where you have like multiple pages full of annotations with different configuration. This definitely makes it tedious, and it's basically, it's not nice. So the new rising star, Gateway API. Gateway API allows you to do north-south traffic. So Ingress, traffic coming from the outside into my cluster. And also east-west, so typically mesh traffic, and you can share the same configuration. Not all companies have adapted both of these APIs, and I would still say that the mesh side of Gateway API is not GA yet, but it's definitely something which will be there in the future and may simplify your life, because you won't need to install so many software components and take care of them. So what are typical Gateway API features? So number one, it's a Kubernetes networking SIG project. So this means it belongs to the special interest group. And this basically more or less says, okay, this project is going to have a future within the Kubernetes ecosystem. It's already been adopted by multiple companies. People are talking about it within the SIG group. And this definitely is normally a success story. You have layer 4 and layer 7 routing, so you can do all of your application routing, rewriting, anything else that you may want to do, inject stuff into headers. You have an Ingress implementation, so you can still continue using Ingress with Gateway API. This is also possible. And load balancing, of course, and also a service mesh API, which you can use. As I said, I've not tested the service mesh API myself. It's something I still would like to do. As far as I've understood from the documentation, this is still in early stages. And one thing which also existed in Ingress, but has been greatly improved in Gateway API, is the role-orientated approach with personas. I'll get to this in the next slide, and I can basically explain more about this. So at the top level of the Gateway API resources, you would have gateway classes. So a gateway class can be deployed by the controller, or in the case of Cilium, it's deployed with the CNI itself. So if you deploy Cilium with the Gateway API feature enabled, after you have finished the installation, you have a gateway class. This gateway class does nothing on its own. To actually utilize Gateway API, you are going to have to deploy a gateway. A gateway is typically an endpoint for incoming traffic. So this would be something like an elastic load balancer in AWS, or any form of load balancing in bare metal, maybe something like Metal LB or something that you could use to get the public IP address and route traffic towards your gateway. So this is something that people are already familiar with if you've been using Ingress in the past. Something which is completely new is the route concept. If anyone's ever worked with Red Hat OpenShift, then they could sound familiar. It is very familiar, and you basically have certain types of routes to map traffic to Kubernetes services. Which routes actually exist? So there's like HTTP routes. HTTP routes may be slightly confusing. This can also be TLS as well. The main difference to TLS routes is TLS routes will typically route your TLS traffic to your service. So it's basically going to encrypt the traffic within your cluster as well. This will not happen with an HTTP route, so you can have a certificate in an HTTP route, but this will typically terminate at the gateway. I will show you this in the demo. There's TCP routes. So if you need anything TCP specific, you're not using domains or anything, you can use these. There are UDP routes. So if you have any DNS traffic, anything else that use UDP, you can also utilize Gateway API to do this. And there are also gRPC routes, which could be used for gRPC applications, for instance, Argo CD or something. That will also be possible. So let's go to personas and roles within Gateway API. So the developers of Gateway API have put a lot of thought into different personas and roles. You may not have all these roles or personas within your company or your organization. This does not really matter. Some of these personas could also be one person. So typically at the top, we would have someone like the infrastructure provider. The infrastructure provider could be someone that deploys a Kubernetes cluster for you and also deploys something like Cilium CNI and would give you a gateway class. So would give you the ability to install a gateway. You may not want every application developer to be able to deploy their own gateways. Why? Because a gateway norm typically means a public IP address, as I said. It's got an AWS load balancer or a Meta LB load balancer, something like that in front of it. And this would definitely be a new gateway into your cluster. So maybe you would like someone else to ensure that this is done in the correct way and some form of cost control over it if you're working with one of the hyperscalers. So this could be a cluster operator that deploys a gateway. And then underneath, you would have application developers that could then deploy their TLS route or their HTTP route, which then points to the service. And typically, the HTTP routes or the TLS routes are deployed in the same namespace as the application itself. So you can have a gateway class, which is a global resource within your Kubernetes cluster. You could have a gateway, which can be shared or non-shared between multiple application developers, depending on how you would like to set this up. There's different ways to do this. And once you've deployed all of this, you would then have your application developer just deploy his own route within the namespace he's deploying his applications. So you can already see you could have cross-namespace traffic. You can use RBAC, for instance, to ensure that all the permissions are set up correctly. Okay, migrating Ingress rules. Quickly go through this. So there's something called Ingress the Gateway that one of the developers from Gateway API wrote. You probably don't need this unless you've got hundreds of Ingress rules that you want to migrate. It could probably make more sense to actually sit down and have a look at your existing Ingress rules and convert them. It's also a learning process which comes with it as well, that you basically get to learn a bit more about how Gateway API works. It's also a Kubernetes SIG project, and it has support for multiple Ingress providers, so you can use like different ones when you call the Go binary, and you can basically download it here and use it. Fairly, not much to do really, except like start it and point it to a directory with YAML, with your existing Ingress rules. Okay, so next up, Cilium CNI. So Cilium CNI, as I said, is a biased choice by myself. I really like Cilium and happy to see some people from iSurveillance listening. Hi, Liz. And it's basically ePBF, so it's the extended Berkeley packet filter behind this. This basically means that you can run microcode within your kernel on your machine. So this will allow you to do a lot of things, and it's very powerful. I will give you a small demonstration on how you can use it for observability purposes in the demo. But basically, this would allow you to monitor anything, any in- or outgoing connections from the kernel. You have native routing, BGP, and layer 2 routing. Native routing basically is a super good idea to make your pods first-class citizens within your network. Your pods can receive an IP address which is directly reachable within your network and all the connected VPNs or cross-connects that you have. And it also increased the network performance greatly if you were using IP encapsulation before. When we changed this, we saw about 25% increase on network throughput. So it's been an awesome experience actually just switching on this feature. You get Ingress, Gateway API, Service Mesh, and the Envoy proxy. No extra controller really needed. So, or yes and no, there is an extra controller, Envoy proxy, but you don't need to install anything extra. You just install Cilium and you get all of these features, which I find is really nice. And for us as a cloud service provider, this has made life extremely simple because we can just deploy Cilium and we can provide customers with all these features. You can switch on WireGuard network encryption. So this would be maybe also an alternative to something like a mutual TLS if you would like to. And you can ensure that all your network encryption is encrypted. And this is also something which just works out of the box. There's nothing you need to do for this. Except activate WireGuard network encryption in the Helm chart values or in your YAML that you're deploying. And everything else is done for you. You get the observability layer with Hubble. Hubble is super powerful. Hubble offers you a really nice CLI client, which I find really powerful. It allows you to do network debugging, which can be super complex in a Kubernetes cluster. If you're running hundreds of pods across a lot of nodes, this can be complex. You've also got a nice UI if you prefer, if you're kind of more of a visual person. You can also use the UI, and it basically understands Kubernetes. It separates everything into individual namespaces and pods, and you can see directly what's going on. You also get network policies. As I said earlier, I can only encourage you to use these. And last but not least, there's a nice, awesome feature called Cluster Mesh, which basically allows you to have two clusters even across different cloud regions and connect these clusters to each other. And this will then allow you to have fault tolerance and other things that you can do with a multi-cluster setup without having to leverage any specific cloud service provider stuff, which may mean a vendor lock-in, because you could just transfer this to another data center if you wanted to. So some of the Gateway API Envoy issues I encountered during setting up my demo. So currently Envoy does not run on Raspberry Pi due to a tmalloc allocation error. This could be easily fixed. Solution 1, recompile your kernel and change this if you want to. I actually tried this on a Raspberry Pi 5. It took about 20 minutes, so it was like fairly quick. You need to change this setting. This is something which is you will find in Raspberry only. Solution 2 would be to recompile Envoy. I didn't try this, and I thought this could be a bit tedious with updating Cilium and everything. So you would basically need to define tcmalloc with gperf tools and recompile Envoy. Or solution 3, use Debian or Ubuntu Lite. As I said, this issue only exists on ARM with Raspbian. I also had an issue where I was encountering 503s when the Envoy pod was on the same node as the application pod. As far as I know, this bug is still open and has not been 100% fixed yet. It's definitely an issue, or can be an issue for some people. In my demo cluster, I basically used taints and tolerations, or you could use anti-affinities to ensure that the Envoy and the application pods run on different or on separate nodes. And I also found that the gRPC routes were broken with TLS. I believe this has been fixed, though, recently. Okay, so now down to the demo prerequisites. What did I actually set up to get all this working? So I installed Cilium, of course, in my demo cluster. These are basically the only options that you really need. You need to ensure that you do not use kubeproxy anymore, so the standard kubeproxy. Instead, Cilium takes care of doing all of the kubeproxy work, and you set the gateway API enabled to true. Layer 7 features are already enabled within Cilium. And if you're using a recent version of Cilium, you will also get Envoy as a separate daemon set. Before Envoy was incorporated, the binary was in the Cilium agent itself. This has been changed as a default. You can still switch it to the old way if you want to, but I think this makes sense because it allows you to get individual metrics. It allows you to set up the resource consumption of Envoy individually, because this will be greatly different than that of the Cilium agent. So this gives you more flexibility. Then this is a manual step at the moment. I'm sure this will change very soon. You need to install the Gateway API CRDs. This is all explained either on the Gateway API page, or you can also find information in the docs of Cilium how to do this. I also installed the Cert Manager Helm chart, so we can get a TLS certificate. And I installed external DNS to ensure that the domain that we'll be using in the demo gets added to Route 53, and yeah, we can just get DNS resolution. Okay, demo time. Let's hope this works. Okay. Let's see, is this large enough? Yeah, it looks good. Okay. So first off, we have a Kubernetes cluster here. Nodes. So we have like a few nodes and also a few namespaces. I should make this a bit larger myself. There's nothing deployed from Gateway API yet, and what I'm going to do first is I'm going to deploy Gateway API. Oops. And while I need to do this first because this takes a while, because it's going to set up a load balancer and everything in the background. So what I've done, I've basically created a namespace called infra. Oops. And in infra, you will find a gateway. And it also has a corresponding service. And the corresponding service is still pending. This will be a load balancer service publishing 2 ports, port 80 and 443. While this is working, we can quickly have a look at the YAML, and I can quickly go through what is actually going on here and what I've actually deployed. So this is the Gateway API YAML that I just deployed. So I deployed a namespace called infra, and underneath I deployed the Gateway API. I called it shared gateway. And I also give it the annotation for the Let's Encrypt certificate, or for the cluster issuer, so it's going to deploy a certificate. The gateway class I'm using is Cilium. I'll show you this in a minute. And I'm opening up 2 ports. So I'm opening up port 80, and I'm allowing routes from all namespaces. So theoretically, you can limit this. You can limit this to certain labels, to certain namespaces. There's different ways of doing this. So you don't have to basically have your Gateway API or your gateway running for all of the namespaces. I just did this for simplicity reasons. Then I also open up an HTTPS port, and I'm requesting with this a certificate, a wildcard certificate, for the TLS traffic. And I'm also allowing all the routes. So let's have a quick look and see if we can. So you should be able to see that we also have the class, which I didn't actually show you. So this is the class that was deployed with Cilium. You get the Gateway API controller, it's accepted. And let's check and see what our gateway looks like and see if this also works. Oops, maybe the info namespace. So if everything works fine, then we should also get an IP address. Yes, we did. So we received an IP address. And if we quickly do a curl, let's quickly shove this up, then we should hopefully get an answer. Yep, we do. And the answer is 404. We're not sending any type of host header or anything else. So we basically get a 404 as an answer. Next up, I would deploy a demo application. So we've got something to look at. So I have 2 demo applications. I'll just deploy this one first. It's going to create a namespace called web app with 2 simple pods in it and also a service. So nothing more, something you're probably familiar with. And next up, we're going to try and route some traffic to this service. So to do this, we need to create a route. And in the Gateway API, I already have an HTTP route. I'll quickly show you what this looks like. And then we can have a look at it. Here it is. So this is a very simple HTTP route. It's only accepting HTTP traffic on port 80. So we basically have our host name, and first off the name of the route, of course, web app HTTP route. We have a host name. We have a parent reference, which is my shared gateway, which I deployed. So it's basically pointing there. If, for instance, you had some form of restriction on your gateway, it would stop you using it. And it also matches certain rules. This is like the simplest rule you can do, so it just matches everything. You can do a lot more complex stuff than this. So you can do like different filters, URL rewriting, you can inject headers, you can do all this stuff. And last but not least, we're pointing to this service. So hopefully, this should have triggered external DNS. Let's have a quick look. And external DNS should have added this record to Route 53. It has, and let's quickly do a curl on it and see if we actually get an answer. Yes, so we get an answer from the HTTP application. It's running. You can see that it's being served by Envoy, and everything's up and running. And during the process of deploying the gateway, we also deployed a certificate with Cert Manager. Let's quickly have a look if this is there as well. So we should have a secret in the infra namespace. We do. We have the wildcard TLS certificate that I requested. So Certificate Manager basically went to Let's Encrypt and issued this certificate. So next up would be, let's have a look and see if we can get some encrypted traffic. So to do this, we would need to, let's do an apply, because we can just overwrite this. We can just basically use the HTTPS redirect to do this. So let's have a quick look at it and show you what's going on. So HTTPS redirect. So same top YAML as we saw earlier. The only difference here is the filter. So in the filter, you can see that I'm using an existing filter of Gateway API to do a request redirect. I'm giving it a 301, and I'm redirecting it to HTTPS. And underneath, we have the second route. So that, as I said, this could be confusing because this HTTP route is also accepting HTTPS traffic. It's just not encrypted into my pod. So it gets terminated at the gateway. So this then should accept TLS traffic and encrypt it. So let's have a look if this actually works. So if we do the same curl and maybe just add something like a capital L, then hopefully we should get redirected. Yeah, we do. So it looks like HTTPS is actually working. Let's have a quick look in a browser and see if this looks good. So we open up a browser and type in our URL, and hopefully we should see my wonderful web application. Yes, we do. And let's see if load balancing also works between the pods. So we should see the pod names change. Yes, pods and IP addresses are changing, so routing also works. And we can have a quick look. We should have our connection is secure, and we should have our wildcard certificate that we just issued on the 3rd of September, just a minute ago. Okay, so now we have Gateway API working, we've deployed our first application, and everything is looking good. But on top of this, what do we want to do? We also want to deploy a second version of our application. So to do this, we can deploy a second version of our web app application. And this is the shiny new version. We want to do some traffic splitting between these two. So if we create, apply, of course. I want to update the existing gateway API. Let's do an HTTPS redirect split. And let's have a look at that YAML. And you can see, I'm not going to go through the top because it's not of interest. We already talked about this. So if you look at the bottom, you can see we now have 2 backend references, and we have a weight of 50-50. You can change this at any time. This can be updated. This will allow Gateway API to make a decision where the traffic is going. So let's have a look and see if this works. And this is all stuff which is already built into Gateway API, so you don't have to do anything else to already get this. So if we do this now, whoa, yes, we can see a shiny new version of my brilliant web application in red. Nice. So this is also working. Traffic splitting is working. Just to quickly show you, did you believe me? I have a second service. And there's the service that you saw in the YAML, Web App Service 1 and 2. Okay, so last up in the demo is I would quickly like to show you how you can actually use Hubble to actually visualize this traffic. So within Hubble, you can basically, if you want to, you can just do a port forward to the Hubble pod running in my cluster. You could also call the UI as well, if you wanted to. And I can then basically switch on and create some traffic. And if I, in the second tab, I could do something like an observe, so we can even do it with an HTTP method get, and we should shortly see requests hitting the cluster, hopefully. Let's see. Come on, don't let me down. Now it's coming. Okay, great. So you could see, as I said earlier, Hubble does a lot of the magic for you. You can already see, I'll quickly stop this, that you have IP addresses, you have ingress, you have the namespace where the traffic is coming in, on which port it's coming from world. It's an HTTP request which is getting forwarded, and you can see the information at which domain it is hitting. And this can be super helpful when you're debugging existing pods, applications in any of your Kubernetes clusters. You can also, I'm not going to go into this any deeper because I don't have enough time, but you can also, of course, use this UI that I spoke about, and you can also see on the left that you have all the namespaces which are available in the cluster to use. So that would be the end of my demo. And if you would like to follow any of this at home, I have put most of the things that I did in this, or all of the things I did in this demo on GitHub. So you can definitely give it a try out at home if you would like to. And thank you very much for your attention and for listening. I hope you have a great container days and enjoy it as much as I have. And if there's anything else you would like to talk about, or if you have any questions, I can take them now. But anything else to talk about, please feel free to drop by our booth, and then I can speak to you about anything Gateway API related. Thank you very much.
Very nice talk. Very interesting. Thank you so much. We have, for now, 3 questions, but I'm pretty sure that most of them will coming up in the next minutes. So the first one is, what other solutions are there for Gateway API other than Cilium?
Yeah, great question. So you've got Nginx Fabric, which you could utilize at the moment. You have Kong Gateway, which you could utilize. Traffic. And there are probably a few other available. I just can't think of any more at the moment, but I think that should be a good selection.
Do you think that there will be more Gateway API-enabled solution that will raise in the next month or year?
I think so, yeah. I'm pretty sure about this.
All right. Is IPv6 supported? Oh, that's a tough question.
Yes, it is. IPv6 is completely supported and can be used. Yeah.
As a double stack? Like IPv4 and IPv6 at the same time?
I haven't tried this myself. I believe it should be.
Okay, got it.
Because, I mean, as long as your cloud provider's load balancer can support this, I'm sure this should work. Cilium definitely supports IPv6, so I don't really see any issues there.
So far, so good. Thank you. Could you use the traffic splitting to do canary releases? Is mirror traffic for dark releases also supported?
I'm not sure about this one. I think so, but I'm not 100% sure, so I'd maybe like to skip an answer here.
Thanks. And the last question is, why gRPC specifically?
gRPC is used by various types of applications. If you have a look at some of the Google demos, you will see that there's like various gRPC demo applications available. There's things like Argo CD and other gRPC applications, which also need to be published to the outside world. And yeah, that's why you basically get gRPC routes.
All right, let's get one last question then. Since the Nginx Ingress controller might have a large resource impact, do you have any experience about resource consumption using the Gateway API?
I didn't see any difference in resource consumption. Maybe it was a bit less, but I would say it's like around about the same. I don't really see any much differences. So anything that you're already running on Envoy should be exactly the same in the case of using it with Cilium like I showed in the demo.
Got it. We have more questions coming up, but this is the lunch break. So let's get the last two questions that comes up and then close the session. There we are. All right. Is zone-aware routing supported by the Gateway API?
As far as I know, no.
Pretty clear. What security issues, possibilities can be opened by Cilium CNI? I don't think there's that much, but anyway.
No.
You confirm?
Yeah, definitely.
Okay. All right. Let's close the sessions, the question session for now. If you have any more questions, then please join Simon in the Sys11 booth. Thanks a ton for your talk.
Thank you.